Hello everyone, welcome to a brand new series of lectures on physics. And to start with this brand new series, I have picked up a very basic topic which one must know and understand before we start with the subsequent topics in physics, which is electrostatics. And electrostatics is a basic topic which we must understand in order to be able to understand various laws and subsequent topics. And to start with, we must understand what is electric charge. Now, because electrostatics is nothing without a charge, so when we talk about electric charge is an intrinsic characteristic of the fundamental particles which are making up those objects. It could be any object. Any object, the fundamental particle of that particular object is the characteristic property of that fundamental particle is the charge. So charge is by default it is there, and charge can be of two types. It can be either positive or negative depending upon the sharing of the electrons in the outermost shell. So and to further elaborate it, I would say that the charged objects, because every object has a fundamental particle and every fundamental particle has this inbuilt intrinsic characteristic of carrying a charge. So the charged objects interact with each other by exerting forces on one another. So every charged object, whether it is neutral or it is positively charged or negatively charged, interact with each other and exert certain forces among the charges. And these forces which are existing between various charges is given by none other than the Coulomb's and is known as the Coulomb's law. So Coulomb's law is basically a law which tells us about the magnitude and the direction of the force which is existing between two charges. And when we'll elaborate this, we can find out a force, or the force of attraction or the force of repulsion depending upon the charges, can also be determined on a single charge due to a number of charges existing in the vicinity. So the basic Coulomb's law gives us the expression for the electrostatic force of maybe attraction or repulsion depending upon the nature of the charge between two charges. So let's see what actually is Coulomb's law. If we take two charges having different values Q1 and Q2, these are the magnitudes Q1 and Q2 is the charge magnitude of two charged particles. I am not specifying the whether it is a positive charge or a negative charge. So, and they are separated by a distance r. Let us say if I have a charge Q1 and a charge Q2 which are separated by a distance r, then these two charges have to have an interaction in the form of the electrostatic forces. Now this electrostatic force is directly proportional to the product of the charges Q1 and Q2, and it is inversely proportional to the square of the distance between the two charges Q1 and Q2. So combining, we can say that the force of attraction or repulsion which is existing between the charges Q1 and Q2 is directly proportional to Q1 Q2 upon r square. And when we remove this sign of proportionality, we introduce a constant K. Now this constant K depends upon the nature of the medium in which these two charges Q1 and Q2 are placed. This medium could be a vacuum, air, water, any medium. So depending on the nature of that particular medium, the value of K will change. Now this constant K is equal to 1 upon 4 pi epsilon naught. 4 is a constant, pi has its own definite value. Now this parameter epsilon naught will decide the value of k, and as I've just mentioned that k depends upon the medium, so which implies that epsilon naught is, or epsilon is different for different mediums. When I say epsilon naught, I am specifically talking about the absolute permittivity of free space. So epsilon naught is an absolute value which tells us about the permittivity of free space, or in other words, how easily the space can transmit charge from one place to another, and it has a specific constant value which is given by 8.85 into 10 to the power minus 12 Coulomb square per Newton per meter square. So that becomes the units of epsilon naught. So putting the values of 4 and pi, 1 upon 4 pi epsilon naught, that means k in this particular case takes the value of 9 into 10 to the power 9 Newton per meter square per Coulomb square. So these units comes from here. If I take all these quantities to the left hand side, and the units of k can be calculated as Newton meter square per Coulomb square. So that gives me the value of epsilon naught and also k if the charges, or the two charges separated by a distance r, are placed in free space having the absolute permittivity to be equal to epsilon naught. Further, we can also say that this physical arrangement of two charges is defined in a quantitative form by the Coulomb's law of electrostatic force. And let me also tell you that the term electrostatic is used to emphasize here. Electro means charge and static means which is not moving. So the term electrostatic emphasizes that relative to each other, the charges are either stationary or moving only very slowly. So from there comes the term electrostatic. Further, under this, I would also like to mention here that this expression, this mathematical or the quantitative form of this Coulomb's law, there is absolutely no exception to this law. So far, no exception has been found for this particular law. So it holds good in each and every given conditions. And I would also like to compare this Coulomb's law of electrostatic force with a similar law. If you see, if I write the Newton's equation for gravitational force, which is F equal to G m1 m2 upon r square, I would just like you to concentrate, I would want you to concentrate on this equation of force given by Coulomb's law and this equation of force given by Newton. This is the electrostatic force of attraction or repulsion which is existing between two different charges, whereas this is the gravitational force of attraction which is existing between two masses m1 and m2, again separated by a distance r. Both these laws are based on the inverse square law, as you can see from the mathematical expression. Now, the point of similarity between these two laws is that it follows the inverse square law rule for both the Coulomb's law and the Newton's law, and the law differs in the fact that the gravitational forces are always attractive in nature, whereas the electrostatic forces are both attractive and repulsive. So this could also be related to the fact that the mass is only of one type. It can only take different values in terms of magnitude, whereas the charges are of two different nature. one is the positive and second is the negative charge. So owing to two different kind of charges, we have two different kind of electrostatic forces, whereas owing to only one particular type of mass, we have only one type of force when we talk about the force of gravity or the gravitational force. So this is one analogy or similarity which I wanted to discuss under this specific topic. And now I'll talk about the definition of 1 Coulomb. What exactly is 1 Coulomb? Now, when I want to describe or define 1 Coulomb, I would take up this Coulomb's law. I'll simply write down F is equal to K Q1 Q2 upon R square, and if I assume that Q1 is equal to Q2 is equal to Q, and which means that the two charges are same in magnitude, both the charges are having the same magnitude of Q, separated by a distance of, let us say, 1 meter. I'll talk about in the SI units, and exerting a force of 1 Newton. If I put these values here, what I get is 1 equal to K into Q square upon 1 implies Q is equal to plus minus 1 Coulomb, which means that a charge of 1 Coulomb or 1 Coulomb is that charge which exerts a force of 1 Newton when placed 1 meter apart from a similar charge in free space. So that becomes the definition of 1 Coulomb. And similarity with Newton's law, I've just discussed it here, the similarity and comparison between the electrostatics force of attraction and repulsion when compared to the gravitational force of attraction. It follows the same inverse square law. So the similarity is the inverse square law is the only point of similarity, whereas the two forces are different in nature, as the electrostatic forces can either be a force of attraction or a force of repulsion, whereas the gravitational force is always attractive in nature, owing to the fact that the charges are of two different types, whereas mass is of one type only. So that is the basic tutorial on Coulomb's law. What is a charge? What is the quantitative expression for the Coulomb's law or the electrostatic force, and its comparison in with the Newton's law of gravitation. So I hope this quick tutorial, or the very basic tutorial, was helpful in brushing up on the basic concepts of the electrostatic forces, charges, and I'll see you in the next tutorials coming up further in the series. Thank you for stopping by and watching the video. Have a good day. Bye.